I ran one command before going to bed, and my AI agent built me out 6 microservices that didn't even exist before and created me a whole entire marketing campaign by the time I woke up. We're talking about ad copy generated in 5 different tones, including Taglish. We have event posters that are all AI generated. We have Wix website events posted, and we have social media ready content for every single platform. Let's go. So essentially, instead of building out complex agent orchestration like most people are doing, I'm just going to be using a for loop, basically the Ralph loop. So one of the first things I want to add before I move on is to make sure that I'm creating a permissions list for all the things that might stop Claude code from running or ask for permission before moving forward, so that we can kind of get surgical and allow the Ralph loop to never stop or never have any human having to press a button before it makes a decision and builds out one of the services. And the way I did that was basically tell Claude Code to read what's going on in the project and come up with ideas of how we should add things into the permissions folder to make sure that everything runs smoothly. So if you remember, or if you watched the previous video, I had already built out 2 services. One was called the Brief Enricher, and one was called the Copywriter. And technically I built 3 services because we were using it all on Docker. So 3 down, 5 more to go, I believe. We have the Wix Publisher, the Social Formatter, the Orchestrator, the Image Gen, and as well as the full entire Docker stack. So yeah, just to go through what we've already built, you can see here, what the fuck? So if we take a look at our PRD document from the first video, you can see that the first services, 3 services, have passed to true, so that the Ralph loop knows which service to work on next and what to do. If you take a look at the progress.txt as well, it has given us basically the memory of what has happened between all the runs on Claude Code and the building of the features. And it tells us what exactly has happened, all the tests, all the reviews that have been done, if they've been Dockerized. Yeah, it just tells us basically all the changes that have been made, as well as the agents being used, as well as the key learnings, which is great. So we have 3 done. We've got 5 to go. We've got the Image Gen, the Orchestrator, the Social Formatter, the Wix Publisher. So in video 1, I was the Orchestrator. I was the one manually calling the agents, reviewing their work, and approving everything. But today we're just going to hand it off to the script. You can see a natural progression here from human orchestrator to an automated orchestrator like we're doing today, to having no orchestration at all. So in video 1, I was kind of like the B thread, the thread that managed all other threads. But today, Ralph is going to take that job away from me. Let me introduce you now to the Ralph loop. This is basically what it does. It reads the plans, the prd.json, finds where the next feature is, where it passes equals false, and then it spawns out Claude Code with the Claude MD plus the PRD plus the progress text, and then it builds the feature, runs the test, and if it passes, it updates that prd.json, logs to the progress, and then git commits, and then loops until the next feature. So you can see how this will keep running even if I'm not here to approve things. It will review itself, approve itself, and be able to create the next feature. So basically, a for loop, a PRD, and a progress.txt file is all you need to ship code while you're sleeping. So I spent video 1 showing you sub-agent architecture, how to orchestrate them, and using some pretty advanced workflows. And the tool that can automate all of that is basically just a bash script with a while loop. So yeah, this PRD document, it is basically not only a to-do list, but a validation check. It's basically a requirements doc that allows us to run tests, and when the tests are validated, the requirement is fulfilled and it can move down the list. So most teams have like a spec doc, a Jira board, and like a progress tracker. This document basically takes all of those things and puts it in one place. So when Ralph reads it, it knows what to build, where it is at in the build. And basically the pass tag makes it the simplest text validation queue in the world. So yeah, just looking towards the future for like 10 features, JSON file works just fine. But for like 200 features, if we're making it look more like a production front-end heavy kind of build, you'd want to use a database. So in this case, probably something like SQLite. And then beyond that, probably use MCP builds instead of Bash. But yeah, that's a topic for another video. And the progress.txt is basically the agent's memory. It tells you everything about what it's built, what kind of issues it had run into, which is very important, and what to expect next. It's what the next feature will read as well before moving forward and building something out. So agents without a persistent memory are kind of like, shift workers who don't leave notes. Basically, the same problems will be passed on from each iteration to each iteration. Things such as rate limits on APIs and stuff of that nature, they all sit in this document. After each iteration, it is committed to Git. So even if this TXT is corrupted in any way, the Git acts as the version history as well. And in this sense, it's not just version history, but it's also long-term agent memory, providing a full history and a full record of everything. So before I let Ralph run overnight, let me show you exactly what happens at each step. I'm going to use the human in the loop version of Ralph. It's the same logic, but it can pause so I can explain. So I'll run this first to get Ralph working. And you can see it's going to walk me through here. And basically this is an example of an L thread, which is a long running thread. But for now, I'll be keeping my hands on the wheel. It's designed for extended work, where it's a lot of base chains just chained together with a persistent state in between them. Basically, this Ralph once will show you each base thread one at a time, whereas the full Ralph loop will just chain them all together. So now you can see that it's saying next up, feature 4, the next thing that we're going to be building, the acceptance criteria for that to test against. And just to reiterate again, we do have permissions here that allows our Ralph loop to continuously run without having to ask for permissions from the user every 5 seconds. So yeah, Ralph found feature 4. It sees 1 and 3 are done from the last video. The image generator is next. So look at the prompt that it's created. It's going to have the prd and the progress.txt explaining what has happened in the previous iterations. And that's basically all the context that the agent is going to need. So basically we have the prompt, which is right here. We have all the context, which is from the Claude MD file, the prd, and the progress.txt. The model is whatever it chooses to use here. And then the prompt is dynamically constructed by the acceptance criteria here. And the tools are all the tests, the Docker, the APIs that we're going to call. And you can see that Ralph is optimizing on every single thing and every single iteration pretty much automatically. I also want you to notice basically what I've put into the prd. I just wrote what the service should do, and accept all variants of that, generating images and stuff like that. I didn't write how it should implement it because I'm not designing the code. I'm just designing the product. And the AI is supposed to figure out all the implementation anyways. So I'm basically shifting from a developer to a product designer. And, this is a huge identity shift when it comes to building out these products for your own business. So now we're just going to let this run. Spawning Claude code. So after waiting a little bit, it had spawned Claude code in the background. And it says that the image generator service is complete. All the acceptance criteria has been met. All that. Claude code finished. Let's validate the work. Running the validation. MyPy, no issues found in 3 source paths. Everything passes. Running the PyTest. Everything is passing here. And it has now updated the prd status. And I'm pretty sure it has already git committed that as well. So you can see it is all run with my assistance, just letting it flow through the proper funnel. So yeah, I guess that would be the critical part right there. To make Ralph really work, you need the feedback loops. It doesn't just trust the agent, it validates, it makes sure that the checks pass, unit tests pass, and only then does it mark a feature as done. So you really need that feedback loop, and without those gates, Ralph would just be marking everything done, whatever you do, whether or not the code works, right? So I just double checked if it committed everything to Git. According to Claude code, it did, and it did write something to the progress.txt, but only appended a minimal 3-line entry, sparse compared to our video 1 notes. I just told it to flesh that out so that we have a full implementation idea with any issues and stuff like that it'll run to. I'm sure there's a way to set up the prompt so that Ralph just does that automatically, or set up Claude code so that just happens automatically. I just push it to do that just so that we can have better contacts moving forward when we start using the infinite Ralph for loop. So yeah, that's one Ralph iteration. We prompt, we build, we validate, commit it. Every step is visible and every step is verified. So now, what if we just try to trust the process? What if we remove ourselves from the loop, right? What about features 5 and 6? The Wix Publisher and the Social Formatter. These services, they don't rely on each other. They don't depend on each other. Wix doesn't need Social. Social doesn't need Wix. So why build one and then the other? Let's try to do a parallel thread where we use 2 agents at the same time, both with isolated contexts, both done in the same time as it takes to do one. If you remember in video 1, I pointed out which services depend on each other and stuff like that. So this is where that's all going to pay off, because although the Wix Publisher and the Social Formatter share an input, which is the copy, they don't really need each other's outputs. So that means we can basically just build them at the same time. And to further explain the P thread, it is just 2 base threads running simultaneously, completely isolated. And neither agent basically knows that the other one exists. They read the same spec. They build different services, but they never interfere each other, basically. So it's just, perfect parallel. If you want to scale your impact, you must scale your compute. So right now in 2 terminals, we're just going to build both feature 6 and feature 5. So now we wait basically to get both of these built out at the same time. I'm going to go get a drink. Okay, so I'm going to run these 2 builds simultaneously, one for feature 5 and one for feature 6. You can see it's reading the scaffolding files, checking Docker files on the other one, existing scaffold for the social formatter, and here we go. We are actually getting everything working in parallel. It is now fixing issues from the testing. One of them has finished, while the other is taking a little bit longer. It's started to implement the features. Here we can see 0 errors and pathing all the PyTests. You can see now it's actually building the service. And we can see all the passes have been made. It'll give us all the logic behind it, and all tests are passed. MyPy has been clean. So feature 6 is also done. Both features done together. 1 in 2 minutes, 1 in 4. So now we are done with 5 and 6. Now we're on to feature 7, which is the Orchestrator. It is a service that's going to call all the other services, and it basically acts as a manager. the funny thing is I'm building it with Ralph, which is itself an orchestrator. So it's an automated orchestrator building an orchestrator service. So it's basically going to be a B thread that builds B threads, and it threads all the way down. So recursively, in video 1, I was basically the B thread. I was managing the subagents. Now Ralph will be the B thread. It's going to manage all the Claude code sessions, and it will be an orchestration service that will basically manage all the 5 other services at the runtime, basically. And you can think of it as like 3 layers of orchestration. It's me, Ralph, and then the orchestrator. And each one is just going to delegate to the next. So now we just basically open another terminal, make sure we're in the right place, and then we can run this file one time. So basically it takes in a number of iterations. We're going to tell it to iterate over everything one time. You can see now it's spawning out Claude, and now we just wait for it to build our feature. Okay, after waiting a little bit, we've seen that feature 7 is complete. Here is a summary of what has been built. Yeah. You might also just want to keep in mind that you should allow all the permissions. You can ask Claude Code how to set that up so that before you even run this Ralph file, you're running it properly so that you're allowing all the permissions. If we take a look at all the git commits, you can see that we are now on the master chain clean with feature 7 as the latest. Feature 8 is up next. Let's get it started on that, shall we? So here you can see in the git we have 7 features. We're on the master clean with feature 7 as the latest. That is 7 features, 7 commits, each one atomic, tested, named. And one thing that I haven't done yet is once we built the orchestrator, it should also retest all of those other services as an orchestrator call. So just to see if the new code has broken the old code. Right now, we're just going to trust that since everything is isolated, it should work. And yeah, that would probably be for another video, but let's continue. We have 7 services built, 3 in video, 1 for today, 3 different types of patterns, thread patterns. And right now, since we're building the infrastructure again, it's going to be another C thread, which is sequential verification, used for infrastructure mainly, right? So it's the same pattern as in video 1, where each step depends on the last, but this time it's going to be based off of 6 services, not just 2, where the stakes are a little bit higher. If one service fails, then the whole pipeline is kind of dead. So we're hoping that everything works well. We're going to want to Docker compose up to get all these containers up and running. That's it. After waiting for a little bit, we have good news. All 6 services are healthy. The full stack is up, and it's asking if we want to hit the health endpoint to verify it's reporting all downstream services as reachable. So there you have it, 6 health checks. This is basically the service level equivalent of the MyPy test passing. So that's what Ralph has done. It has validated that the code is working, the service is booting, and we kind of have a validation from the ground up where it's a health check, a unit test, integration test, visual test, which is basically, helping you build a mental model of validation, basically. So here I'm going to try to do a full pipeline demo. Yeah, so I forgot to update my API keys. I'll go ahead and do that and show you some outputs from everything working. So, okay, as for a full pipeline demo, just for easy use, I'll drag in our images to the project here just to see what it had created. And here you can see that it has made some content and images based off this. And it will save all the captions, all the hashtags or whatever that needs to be added to the files into the correct places on the Airtable that will be coming up in the next video. So you can see here, by protecting our context, we're having better output. The system is actually working through Docker and everything, and this is pretty much the final proof. Taglish is natural, and it basically shows off 6 services, which each have their own identity or their own tasks that they're following. Creating one product that is fully automated, has the brand's tonality in mind, and the quality is preserved throughout the automation. And the best thing about this is that this is real. This is actually for a real business. It's a real event that's going to come up, and it's going to go live on an actual site, right? So you could see here how just even overnight you could spin up products that you might use for your business month in, month out, weekly, daily. If you're creating multiple pieces of content every single day, you could even use it to create systems that scrape other viral pieces of content or do audits on the way that your whole system is built. Basically, the sky's the limit here. You just gotta prompt it correctly and feed in enough context and execute in a way that makes sense for the AI to do its job much better. Overall, in video 1, I was an orchestrator. I spawned agents, I reviewed the outputs, and I approved the steps. And today we let Ralph take over 4 features, 4 different types of threads. The L thread where Ralph with a human in the loop walked me through every single step. The parallel threads where I built 2 services at the same time. The B thread where Ralph built an orchestrator building an orchestrator, and the C thread, which was basically the sequential verification that brought the full stack online using Docker. 4 patterns, 4 features, you just saw all of them. What we can really take away from this is that AI isn't really replacing marketers. It's doing all that repetitive formatting for you so you can focus on a creative strategy and you can let it run while you sleep. In this sense, you can stop thinking about it as development and more as becoming a product designer who just learned how to code. So my job today wasn't writing code, it was more like designing the product. I'm seeing what should each service do, what are the acceptance criteria, and what does the quality look like. And I included it all in a spec, and Ralph wrote the rest of the code. So yeah, that's what you have there. Honestly, if it's quality that you're after, I do believe that this is the approach. It isn't necessarily the fastest. Probably a single long prompt could get you there faster, but you could also produce much more degraded output if you're doing something like that. So this is more like the quality approach where you have validation, automation, and architecture working all together. It takes longer, costs a little bit more tokens, but the output is much better. And in the next video, I'll be connecting all of this to the Airtable that you've seen in the beginning. So when someone adds an event, the entire campaign just generates automatically, 0 touch, no human in the loop at all, and then we'll eventually build out a dashboard for that. So video 1, I'm the manager. Video 2, I automate the manager. And video 3, there is no manager. The pipeline will trigger itself, validate itself, and publish to 5 platforms. That is a 0 touch Z thread, and that's what's coming up next. We're also going to upgrade Ralph a little bit so that it can retest old software that it's built, and we're going to see an actual dashboard and probably turn the 10 features into much more and get Ralph working for a lot longer time. So look forward to that. If anything in this video has sparked an interest for you at all or has taught you anything, drop me a like, save the video, send it. And all of this stuff can be found on a GitHub repo that I'll be sharing out in the description below. So check that out, and I look forward to seeing you in the next video.